This is a GTS Flexxer. It's a 40-foot version. We've got on the front of a CR9070. This platform can go on either CNH or S-Series John Deere combines. It can go on older model John Deeres, but we just have to check a few things. So we've been running this front for, this will be the third season. It's a flex, has a fully flexible knife. So currently it's in rigid mode because we've been harvesting wheat. So those wheat sensors that are hanging down, they touch the ground, and as they move up and down, tell the header to lift or lower or tilt the feeder house based on what they're seeing. So they work within a range. They're just a potentiometer, and obviously the four sensors across the front of the machine sense the ground and yeah, make the front follow the ground. They do a really good job. I'll go and take some video of some pretty wild areas that we did. Yeah, haven't had the front hit the ground yet. We don't harvest very fast down here, probably somewhere between 4 and 8 kilometers an hour, but seems to keep up, no problems at all. Obviously you're not going very fast in those really steep bits. Probably one of the other main differences that compared to some of the other fronts on the market that you look at is that it's function wise it's pretty simple. So knife and your drapers and your drum are all driven by mechanical shafts, so they're all driven off your PDO. You've obviously got your adjustment for your draper speed, plus or minus 10% on each end, so you can change your draper speeds. Your knife speed is set. So then realistically hydraulic functions are pretty limited. You've got up and down on your reel, you've got fore and aft on your reel, you've got one hydraulic drive motor on the left of center to drive your reel, and obviously your reel speed is variable, and you've got the header tilt, or not header tilt, the angle of the header on your top link, which is between your fore and aft, and obviously you're not going very fast in those really steep bits. Aluminium construction, there's obviously back plates across the back. Aluminium construction, they run a direct drive either side of the feeder house, so that direct drive runs to a gearbox here and then along to another gearbox which sets your draper, which is your draper gearbox. This gearbox here runs your drum, so you've got drive off your PDO shaft into this gearbox, then it connects to drives out of the gearbox and along to the feeder drum in the center of the machine. I'll show you the front of that. The back of the machine has a gearbox either side for your draper speeds. Don't know what A, B and M mean, but it's basically like you've got a standard speed, a 10% slower and a 10% faster. Underneath, obviously that's where it drives the belt. That gearbox then connects to the front and connects to your knife drives, which are a Schumacher box. So double knife either side, nothing in the middle to get in your road. They run a Schumacher knife. We've had a lot of rain here, by the way. At 17mm yesterday. The header was in the shed, but we didn't have time to take the fronts off, so the fronts got wet, unfortunately. Yeah, so they run a Schumacher knife. They have the rollers at the top on these ones. I'd have to check the specs on that, but that's what they run. 3-piece reel, it's pretty important. your vision, I'll show you that in a moment. Vision out of the cab is really, really good. Not having that center section of your draper with the big bar really makes for great vision. I know some others out there have got a 3-piece reel now, and I'm sure they're doing, as I was saying before, simplicity wise and vision wise, they're really, really good. So indicator on our top link, 0, 1, 2, 3 and 4, set just between 2 and not quite 3 at the moment, and reel fore and aft is set at about 2.5. Yeah, spending a lot of our time when the crop's down, obviously spending a lot of our time with the reel out. We've had a lot of rain here, so having that on the thing, which is pretty standard on most machines now, is very, very good. So I'll talk about the front in flex mode. So essentially in rigid mode, you've locked it up out of position. So those bolts under there, this is a manual one. They do have a hydraulic lockup from the cab now as an option. It wasn't an option when we ordered this front. So essentially where that bolt is a hinge point, and there's an arm that runs all the way back to the knife. And on the other end of that arm, there's a spring, and that holds the weight of the knife. So when you drop that down, go around the other side and I'll show you. As you can see, it's very wet here at the moment. We've had about 200 mil since the 27th of November, and yeah, we're the 3rd of Jan today, so it's less than ideal harvesting conditions, but it allows us to do little videos like this. I might show you over here, makes sense. So this here is the pivot point connecting to that arm, and that arm runs all the way down to the knife. On top of that arm there's this spring, and that spring runs down and connects to the arm, and that holds the arm and allows it to travel. It travels in this gap here, which works out to be about 200 mil of travel at the knife in any one part. So each individual part of the knife can flex. It's not a sections, it's not 3 sections, it's the whole knife flexes. And if you run out of travel on that knife, there's a potentiometer here. So this linkage arm is telling this potentiometer where it is, and that potentiometer is talking to the cab, doing exactly the same thing as those weight sensors, so they lock up out of position. And that potentiometer there essentially tells the feeder house to raise or lower, or to tilt to the left, tilt to the right. So that's what's controlling the front. So you've got two things happening with this front to allow it to flex, or allow it to follow the ground, I should say. You've got the knife itself has this mechanical movement of roughly 200 mil at the knife. So when you're running in flex mode, those small skid plates, they are what is running on the ground, and you've got roughly 30 kilos of down pressure when this spring is set correctly. If it gets out of its range, then the feeder house of the header takes over and will raise or lower the feeder house. When they're running in flex mode, they've got an indicator on each end. So this indicator will be running in the green. At the moment it's all the way up, which is why it's in the red position, because it's in rigid mode and it's locked up out of position. So when it's running in the green, you'll see this floating along. When you're running in flex mode, I should say, you'll see it running most of the time in the green, and it'll be going either side into the yellow. Once it goes too far into the yellow, that's essentially an indication from the cab, but you'll see that the feeder house of the header will be moving up and down or tilting to make it follow the ground or keep those potentiometers in range. So it's essentially just monitoring those potentiometers all the time and trying to keep them in the center section, so it's got the most range of travel up or down to follow the ground. Seems to do a really, really good job. You'll notice that it's got 2 large tubes, one at the top and one at the bottom with pretty extensive amount of aluminium in them. So this front's a 40 footer, so it comes in a center section and 2 short wings that are bolted here. So it comes in a container form to us, and we bolt these parts on. The whole front weighs about, I'm going to get it wrong here. I'll have to correct myself, but it's a very, very similar weight to an FD75 Flexxer or a Macdon FD1. I don't know about the FT2s, but an FD140, and one of these is about the same. So obviously these are made of aluminium, which is a lighter material, but there seems to be a lot more material in it. Some other differences to other fronts you've seen on the market probably is that the feeder house is rigidly connected to the front. It doesn't have a spring system or a leaf spring underneath like the honeybees used to have, or you know, a spring system like the Macdon has. So the whole header front doesn't float. Doesn't seem to be a problem. I was nervous of that at the start. I've got a background sort of selling Macdon stuff in a former life, and you know, I was probably pretty nervous of that, but because of the way it follows the ground and the way the weight sensors work, it doesn't seem to be a problem. Certainly haven't had any issues, and we've got some pretty hilly country here. So just walking around the other side to show you that. So there's our feeder drum, retractable tine drum. Lots of people call them different things. I call them a retractable tine drum. And walking around this other side here, the right hand side shaft, obviously driving a gearbox, and that gearbox in turn driving our center draper. That center section drops down, so there's a handle at the other side. I won't drop it down because it's a bit of a bugger on your own to get it to latch up again. It's probably a 2-person job. Draper adjustment there. Does seem to build up with stuff underneath that draper drive, that center draper mat. Hasn't been a problem so far, but it does seem to build up in there. There's another potentiometer there you can see. And then pretty much copy paste on the other side, another shaft running out to your draper speed, running straight through that, and then going along to your Schumacher drive, knife drives on the end. Thought I'd just tack on a little bit of footage that we took of it working in lentils up near Birchip. This was roughly a tonne to the hectare crop, sort of north of Birchip on a case combine. Lentils in the bottom of the paddock in this part of the paddock were a little better than up on the rise. The rise was a bit lighter. If you focus on, I guess, the knife and the black guard on the closest side to camera as we zoom in here, what you'll see is you'll start to see the flex. So if you focus on that guard, you'll see it flexing against the rigid backbone. That's sort of a pretty good indication of how they work. So what will be happening there is, as it's going along, the knife will obviously meet ground that's rising, and the mechanical flex, those arms will allow it to lift up. Once it starts to lift up, then the header will compensate by moving the feeder house up to keep that the knife in the middle of its mechanical range. I'm not sure what speed we were actually doing here, but significantly faster than what we would harvest at home. The comment from the farmer who was having a play with this, he said probably the biggest difference he could see between the other fronts that he'd been using was that it really didn't pick up any dirt or soil. Had a really nice clean sample, which can often be a problem in lentils when they've grown so low. He would have rolled this paddock with a steel land roller, I'm sure. Most farmers in his area in the Mallee are doing that now with lentils to try and minimise the amount of dirt that's going on, getting into the sample, and to minimise the cost of cleaning. And here's the GTS working in a little bit of wheat. That's probably enough for this video. It's a pretty long-winded one, longest one I've done. I'm only learning how to sort of edit and cut this stuff together, so if anyone's got any tips or any advice or constructive criticism, please be nice. But yeah, hopefully you learned something from from the video and got a bit of an idea about the GTS fronts. I know a lot of people in Australia haven't seen them yet, so yeah, keen on your feedback.